Algebra 2, we're back. So you just got a worksheet that has 4 problems on it, and you're asked to put this data to an equation and figure out whatever information the equation asks for here. So you're given 3 data points here, and we're asked to find come up with an equation and figure out when it equals 0, right? So we've got the point -2, 5. So we could go 5 equals a times -2 squared, so times 4, plus b times -2 plus c. And then we would have 1 was the result of plugging 0 in, so a times 0 squared, or 0, plus b times 0 plus c. And then 21 is the result of a times 2 squared, or 4, plus b times 2 plus c. Okay, and we'll just assume that you're capable of punching this into a matrix. We could use systems of equations to solve this, but we'll just punch it into a matrix, and we'll get that a equals 3, and b equals 4, and c equals 1. Therefore, the equation is 3x squared plus 4x plus 1. And we're asked to find the values that make that equal to 0. Okay. Now, factoring with what we know so far is not going to be a good option here because we've got this 3 coefficient there. There's a method called the Berry method where you can actually factor with a coefficient, a leading coefficient of something other than 1 for your square term. But let's just use completing the square on this one because it's going to make a little bit more sense. So the first thing we have to do is get a leading coefficient of 1. So we'll divide everything through by 3. 0 divided by 3 is just 0, so that's going to be fine. Now 3x squared divided by 3 is going to be x squared, which is what we want. Plus, and let's divide this by 3, so we get 4/3 x plus 1/3. Now this looks like it's going to be really ugly because you've got these fractions here, but let's just use the whole completing the square method and see where we land. So we're going to take half of this and square it, and hopefully we get something close to this, and we'll adjust this accordingly, right? So half of 4/3 would be 4/6, and then that squared would be, well, 4 squared is 16, and 6 squared, actually, let's not do that. Let's do, well, 4/6 reduces to 2/3, so let's just do that. Half of 4/3 is 2/3. That's going to be easier. So 2/3 squared is going to equal 2 squared is 4, and then 3 squared is 9. So that's going to be 4/9. Okay, so we wish that this was 4/9, but it's not. It's 3/9. So we're going to have to add a 9th to it. Okay, so let's rewrite this. So 4/9 is what we want. So let's rewrite this as x squared plus 4/3 x plus 4/9 minus 1/9. Right? 4/9 minus 1/9 is 3/9, which is 1/3. So this could be rewritten that way, right? So now we know that this breaks down into x plus something squared. And that something is going to be half this. So it'll be x plus 2/3 squared. And then that all is going to equal 1/9. All right, so let me erase what we've got up here. Hopefully you know how to do your matrix stuff by now. So up we go. So we've got x plus 2/3 squared equals 1/9. We could take the square root of both sides. So we get x plus 2/3 equals plus or minus. Now, square root of 1/9 would just be the square root of 1 over the square root of 9, or 1/3. So plus or minus 1/3. Then we could subtract 2/3 from both sides. We get x equals, we have 2 options here. It's going to be 1/3, positive 1/3, minus 2/3. X is also negative 1/3, minus 2/3. Okay, so 1/3 minus 2/3 would be negative 1/3. And then negative 1/3 minus 2/3 would be negative 1. So these are the values that make y 0. So the points negative 1/3, comma 0, and the point negative 1, comma 0 are also part of this curve. So that kind of shows you the beauty of completing the square. Sometimes it may end up looking like ugly numbers, but it ends up working out pretty well if you just kind of take the time to do it. All right, let's take a look at the next problem here. Is that what they asked? Yeah. All right, let's find this next problem here. Okay, we're given the points 0, negative 10, negative 1, 2, and 2, 14. Okay, and then we're asked to find what value is going to cause a negative 6. So at what x value is y negative 6 in this equation? So let's fill out our matrix here. So we get negative 10 is the result of plugging 0 in. So a times 0 plus b times 0 plus c. And then we get 2 is the result of a times negative 1 squared is 1 plus b times negative 1 plus c. And then we get 14 is the result of a times 2 squared, which is 4, plus b times 2 plus c. And go ahead and plug that into your matrix, and you're going to end up with a is 8, b is negative 4, and c is negative 10. So it'd be 8x squared minus 4x minus 10. All right, so I'll go ahead and erase this matrix for some room here. Hopefully you're pretty good at solving that by now. It's not a matrix, it's a system of equations, but anyhow. So we end up with the equation 8x ax squared minus 4x minus 10. Now we're going to set that equal to negative 6, because we're going to see what x value causes that to be negative 6. Now remember, we want a 0 over here if we're going to be solving a quadratic equation. So let's go ahead and add 6 to both sides. So we get 8x squared minus 4x. So minus 10 plus 6 would be minus 4 equals 0, which is what we want. And let's go ahead and divide everything through by 4. So hopefully that makes things a little bit more simple. Okay, so we get 8 divided by 4 is 2x squared minus just x minus 1 equals 0. That's going to make things a lot easier. In fact, actually, let's divide everything by 8 to get a leading coefficient of 1 so we can do a completing the square. We could use the quadratic formula in any of these, but I'm not a fan of that. Let's just complete that square. Let's divide everything by 8. So we get x squared minus 4 divided by 8 is 1/2 x minus 1/2 equals 0. Okay, so we want to find half of this term and square it. That's what we want this to be. Well, half of 1/2 is 1/4, so it'd be negative 1/4, and this all squared is going to be, well, negative 1 squared is 1, and 4 squared is 16. Okay, so we want this to be 1/16. It's not, it's 1/2, but let's rewrite that. So we want this to be 1/16. So we want this to be x squared minus 1/2 x plus 1/16. Let's see. In order to get a 16th down to 1/2, we'd have to subtract, down to negative 1/2, we'd have to subtract a half plus a 16th, which would be 8/16. So we have minus 9/16. So 1/16 minus 9/16 is negative 1/2. Okay, so now we know that this is a perfect square because this is half of this squared. So it's going to land at x minus x plus something squared, and that something is half of this term, so it'd be x plus negative 1/4 squared equals this equals 9/16. Okay, so now we know that x, we'll just call it minus 1/4, so x minus 1/4 equals plus or minus the square root of 9 over 16, so it'd be 3 over 4. So plus or minus 3/4. And hopefully we're out of room here. Let's see, x minus 1/4. So we're going to add 1/4 to both sides. Let's just, actually, let's erase this up here. Let's start from the top again. So x minus 1/4 equals plus or minus 3/4. So x could be positive 3/4 plus 1/4, which equals 1. And x could also be negative 3/4 plus 1/4, which would be negative 1/2. So those are the two values that work for x. So the point 1, negative 6. So an x value of 1 will cause a negative 6, and an x value of negative 1/2 will cause a negative 6. Okay. All right, let's erase this real quick. How much time do we have here? 11 minutes, we're fine. All right, number 3. All right, we're given the point 2, 0, and 5/33, and negative 4, negative 12. Is that right? Oops. Not negative 4, negative 12. We're given negative 6, 0. Negative 4, negative 12 is one of the answers. And we're asked to see which values are going to cause a negative 12. I just told you one of them is negative 4, but we'll pretend you didn't hear that. Okay, so we get this matrix here. So let's do that. So we've got, let's see, 0 is the result of, tell you what, I'm going to assume you know how to plug this into a matrix. So we did that all last week. We could plug 0 equals a times 2 squared plus b times 2 plus c, and then 33 equals a times 5 squared plus b times 5 plus c, and so forth. I'm going to trust that you know how to do that. We're going to save some time and room on the paper here. And just take my word for it, you're going to end up with a equals 1, b equals 4, and c equals negative 12. So we get x squared, 1x squared, plus 4x, minus 12. And we're going to figure out what causes that to be negative 12. Okay. So this one gets a little bit interesting because when we add 12 to both sides, they cancel, right? So we get x squared plus 4x, or add 12 to both sides, so it'd be just x squared plus 4x equals 0. Right, so what we really want is, you could factor this the normal way using the reverse FOIL method, but look what we can do here. We could divide both of these by x, so we could land at x times x plus 4 equals 0. And notice if you distribute this x, you'd get x times x is x squared, x times 4 is 4x. So we could just essentially undistribute that. And now we just need to set either one of these equal to 0. Right? So if x equals 0, that's going to be a solution, because this x is going to cancel everything out. Or if x equals negative 4, that's going to cause this to be 0. Okay? So an x value of 0 or an x value of negative 4 will both cause this to be 0. So those are the solutions to our equation here. So the point 0, negative 12, is a solution. And the point negative 4, negative 12, is a solution, like I accidentally said at the beginning of this problem. Okay, let's erase this and do the last one. Okay, 4 minutes, we're good. Okay. So we're given the points negative 1, 7, and 1, 13, and negative 2, 10. And we're asked to find the zeros. So what causes it to be 0? Well, let's let's take a look at the quadratic formula. Let's take a look at that discriminant to see what we can make of this. So remember the quadratic formula, it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, this is going to tell us how many roots we have, this b squared minus 4ac. If this ends up being positive, then we're going to have 2. If it ends up being 0, we'll have 1. If it ends up being negative, we'll have no roots. So let's see what happens when we plug in b squared minus 4ac. I just realized I forgot to punch this into a matrix. You could come up with your system of equations and come up with the equation 2x squared plus 3x plus 8. And if you don't know how to punch this into a matrix and come up with that, just see me and we'll get that squared away. So we have a b value of 3, an a value of 2, and a c value of 8. So let's see where we land. So b squared, so 3 squared minus 4ac, minus 4 times 2 times 8. And let's see what happens. So 3 squared is 9, minus, so 4 times 2 is 8, 8 times 8 is 64. That equals, what, negative 55. That took me too long to figure out. So we have a negative number here. Okay, so there actually is, so this tells me that there are no roots here. There are no zeros. So there actually, the answer to this would be no solution. Because we know that there are no values that make this 0 because we determined that from the discriminant of this quadratic equation. And we are done. Hope this helped, and come and see me if you've got any questions.